No, you can do it another way.
Morning, students. Steve Brown here. We're going to be going through the final exam, which I think you're writing next Thursday. Just give me a thumbs up. Just give me something that you can hear me, that the mic's working, that there are no issues before we actually start. Anybody out there, just you don't have to say anything. You can either put a thumbs up or something in the chat, which tells me that you can hear me, please. Great. Thank you so much. Thank you for that. I'm going to start bang on. Thank you so much. Thank you, Tanil. I appreciate that. I'm going to start bang on 10. I know you guys have got a lot on your plate, and I don't particularly want to waste your time. So I'm going to get started fairly soon. In fact, now. I'm going to just quickly go through the outline of your paper, what you are expected to do. And because we've done masterclasses through the semester, I'm not going to spend too much time on the earlier stuff. I'm still going to go through it with you, but I'm going to spend a little bit more time on the issues or the modules, or should I say the learning units that you covered towards the end. So I'm going to spend more time on looking at calculating under the probability curves, looking at sampling distributions, and then, of course, our all-time favorites, hypothesis testing. Okay, so I'm going to start right now, and I'm going to start with what your final exam is going to kind of look like. I'm pretty sure your lecturers have told you, but let's just go through it again so that you kind of get a feel for what we're going to be doing. You are going to be faced with a 2-hour, 100-mark paper. It's the first, remember, that we've always done 120 marks in 2 hours. Now it's 100 marks in 2 hours. But the actual outline is going to be fairly similar to what the ones you've seen perhaps in the past or the ones that your lecturers have gone through. So you're going to have you're going to have 4 sections. You're going to have section A, which is going to be compulsory 3 questions, and I'll quickly deal with that. We then have got we got then section B, C, and D. And section B, C, and D are going to be choices, students. So we're going to have choices there. So as we go through it, so section A will comprise, it's going to be your MCQs for your chapter 1. It's then going to deal with an index question, so index numbers, which I'll deal with, and then, of course, our linear regression question. Those are compulsory, students, at section A. I suspect, I haven't seen the paper, but I suspect that'll probably be 40 marks, so a weighting of 40%. And then you've got sections B, C, and D. Section B will be grouped or ungrouped data. Section C will be probability or probability distributions. And section D will be your hypothesis testing, broken down into the hypothesis test and also, or alternatively, chi-tests. But I will deal with that in the course of today. What you need to perhaps remember, as I suspect weightings have changed slightly, so the section A, which is compulsory, which is, as I said, index, chapter 1 and linear, will probably have a 40% weighting, and B, C, and D, which will be 20 marks each, to give you a 60% weighting in that final exam. Okay, so what I'm going to do with you now is I'm going to go through, I'm not going to do much on chapter 1. We kind of know what we need to learn there. It's random variables. How do you define them? What's the difference between qualitative, quantitative data, nominal, ordinal, those kinds of definitional stuff. Class, I honestly suggest just try and go through some of your older papers that you have. They don't change much. What's the weakest form of data? What's the strongest form of data? Those well-known questions. However, what I am going to do now is I'm going to then spend a bit more time, as you can see here, on just going over on index numbers again. Now, you're going to get a question on index numbers. and it'll be divided into 2 points. So if I'm going to show you here from your organogram, we're going to have or I suspect you'll have a question on a simple index, and I'll show you again how we do that calculation. And then class, they will definitely give you either a Parsh or a Las Perez, or indeed they may give you both. I don't know, but we'll quickly go and revise just the basics for those. So that'll be in section A. It'll be compulsory, and I suspect it'll probably be in the region of, I don't know, maybe 10, 15 marks. In terms, so the mark allocation will be downgraded slightly because the paper itself now is out of 100 instead of 120. So let's have a look at a quantity relative or a price relative. So they'll give you 2 types of questions in your index numbers. You'll have a quantity / price relative you'll look at, and then you will either have I don't know, maybe you'll be given both a Las Perez and a Parsh. Okay, so what I'm going to do first of all with you is just very briefly go through a quantity relative with you. So quantity relative class, it will be, so first of all, you must always check what they're asking, whether they're asking for a price or a quantity relative in the question, because there's no use hoofing off and doing a price when there's quantity, etc. So in this situation, I've asked, or I'm just showing you a quantity relative. So you're going to take the quantity. So we're looking at product A in this, and this kind of scenario is very similar to what they're going to give you in the exam. So you'll have, in this situation, got product A, B, and C, and they've asking for a quantity relative for product A. In other words, what's the percentage increase, basically? So you're going to take Q1, which is quantity in the current period, which is 57, divided by quantity in the base period, which is 50. So we have 57 divided by 50. Now, here you can kind of, I don't know what your lecturers have been telling you, but for my own students, you can you put it out in all its glory like this, or you can actually just go across through to 114, and then we'll explain what the 14% is. So we divide 50 into 57, and you get 1.14. Now you convert it into kind of a percent now, or into relative to 100. So you get therefore a 114. So you've taken 1.14 multiplied by 100 to get 114. And then class, remember, you are indexing it to a base of 100. So anything above 100 means it's an increase. Anything below 100 class means it's a decrease. Remember, this is now contextualizing it to a base of 100. In this situation, you're basing it to 100. So 100 is your base. You've got 114, so therefore it is a 14% increase over the base period of that quantity. So quantity effectively has risen 14% over that period. Okay, it could be again a price. If it was, I'm not going to do that particular example, but if it was a price index or a price relative that they looked for, that would be 209.4 divided by 207. Okay, so it's always going to be your current divided by your base. If the number here, class, had been less than 100, therefore it would have been a decrease. So if, for instance, the number here had come out as 90, therefore 90 is below 100, it would therefore have been a 10% decrease. All right, so you would have taken your 90, minused it from 100, and said that was a decrease. Those are your quantity and price relatives. There's a very good chance that you're going to get one or two of those, actually. So please remember, A, rule of thumb, check what they're asking for. Is it quantity or a price? And then B, just making sure you put that answer into a percent, please. Don't leave it as a decimal. I mean, you're not going to, your lecturer will give you marks, but you won't get the full mark process if you leave it as a decimal or like that. Right, so that's the one type of question. The next type of question, class, is going to be either Parsh or Las Perez, or indeed both. Okay, now you may remember that you do get a formula sheet. your lecturer may have given you or shown you what the formula sheet looks like. What I suggest you do is you don't try and learn the formula. The formula will be given to you. Just check that you're using the right one. Always remember, rule of thumb, Parsh is dealing with holding something constant in the current period, and Las Perez is holding something constant in the base period. Now, that something is either price or quantity. Class, generally, they ask you a price, a Las Perez price, or a Parsh price. Okay, what does that mean? It means quite simply, in this example here, we've got a Parsh, so we are going to be holding something constant, and we're going to be holding a constant in the current period. Now, when it's a Parsh price index, it means we're going to be measuring the price changes, so therefore we are going to be holding quantity constant, and because it's Parsh, we're going to be holding it constant in the current period. If this was Las Perez, we would be holding quantity constant in the base period. Right, now because this is Parsh, what we do, and the best way I've taught my students, and I'm pretty sure your lecturers have shown you which way, but for honestly the easiest and quickest way is to immediately, before you do anything else on your exam paper, just put in a fraction like that, put in a line, and then on the top, you know that's your numerator. On the bottom, it's your denominator. Now, with a Parsh price, you know you're going to use this formula, which is P1 multiplied by Q1. Q1, by the way, class, is constant on the top and the bottom. Why? Because it's Parsh, it's constant. And why is it a 1 and a 1? Because it is constant in the current period. Right, so we are going to be doing, and because it's a composite weighted index, it means, class, that we are going to be dealing with all, and generally they're going to give you 3 commodities or items to deal with. So you're going to have 3 calculations on your numerator and 3 calculations on your denominator. Okay, so here we start, and we just kind of follow the formula if we forget. It says P1, which means it is current. Whenever you see a 1, either P or Q, it means it's current, class. So we're going to the current price, and they're very nice. They're going to tell you it's P1, and sorry, it should be a Q, and they'll say when it's base, it'll be 0 and 0. You're going to start 209.4. Why? That's your first product, and we're going to take the first price multiplied by the quantity in the current period. Moving forward, 3128 multiplied by the quantity in the current period, 225.7 multiplied by the quantity in the current period. Why is it in the current period, class? It's because it's a Parsh index. If it was Las Perez, you would be dealing with this column, but I'm not. Let's not kind of muddy the waters here. Right, that's your numerator. On the denominator, the quick way to do this is, you know that Q1 is going to be the same on the top and the bottom. So with 57, 55, 43, 57, 55, 43, you're just going to stick it in at the bottom as well. Why? That's what your formula is telling you. And remembering, you're holding quantity constant in the current period. Then you are going to follow what your formula says again. Take your price, P0. This time for product A, 207 multiplied by 57, 315 multiplied by 55, 225.7 multiplied by 43. Check, run your eye over it before you do your final calc. Make sure, if it is Parsh, class, that your quantities are going to be held constant in the current period. That means these numbers here must appear on the top and the bottom. If you're dealing with Las Perez and you're dealing with a price index, which generally it will be, then you will find these numbers on both the top and the bottom. Okay, do the calculation, and remembering then, please, I suspect will ask you to interpret as well. And in this situation, you've got a very small increase. Why? It is above 100. So don't get your decimals mucked up or muddled up. And then you'll say there's been an average increase over the period, whatever it happened to be, maybe May to September or whatever they've given you. There's been an average increase in this composite weighted index of whatever that number is over the period January to June or whatever they ask you. Please, class, remember to interpret. Please don't leave the interpretation out. You don't have to write piles and piles of stuff, but and I'll come back to this again when we're looking at group to non-group data. Always interpret. Always write something down so that your lecturer can actually give you some marks for it. Don't throw pointless marks away. Okay, so that's index number. So we are looking at section A of the paper. 3 questions of compulsory. The first question will be, I suspect, multiple choice questions on chapter 1 on your basic definitional stuff. Question 2 very possibly will be an index number type question. You'll get a box like this. You'll get some kind of contextualization around it. And then you're remembering that this side of the box is going to be your base period. This side of the box will be your current period. Remembering to use your formula from your formula sheet. Just check what they're asking you for, whether it's a Pasch or a Las Perez, or they may ask both. And also check, please, class, if they're asking you either for a price or a quantity relative to do that calculation correctly. So that's index numbers. Right, next one in the last part of section A is going to be your regression. Again, students, you're going to get the formulae. Okay, the formulae are given in the formula sheet. Again, here's a rule of thumb. Maybe it'll help you. As soon as you are allowed to start, and take this from me now. As soon as your invigilator says start, the very first thing you do is remove the tables and the formula sheet from the back of your question paper and put it in front of you. Because the last thing you want to keep doing is turning over your question paper, trying to find the formula sheet, trying to find the tables. You'll be using tables in probability and in hypothesis testing. Just get them right in front of you now. Make sure you know what you're going to be looking at. So in a linear equation type question, that'll be the 3rd type question in section A, you will be given, okay, remember what we're supposed to be doing here. There'll be kind of 2 or 3 sections to the question. The first will be to find a best fit line, which is basically of the form y equals a plus bx, which is your linear equation. So what are you really doing? You'll have data and you're fitting a best fit line through it. How are you going to fit this best fit line through it, class? You're going to use this particular formula and you're looking at this formula. Now, in order to be able to complete all of your A's and B's, because you need to find the coefficient B, which is your slope coefficient, and you need to find this thing here, which is actually your y-intercept. Now, you need to find both that, and it doesn't necessarily have to be y equals a plus bx. It can be whatever your lecturer has taught you. Y equals bo plus b1, whatever. It's exactly the same format. You will be finding a number to go there and a number to go there. Now, the important thing to remember before we actually go through the calc quickly is that you have to find this number before you find that number, because this calculation, this A, the number you're going to fit in there, actually requires your number B. So you have to do this before you do that. Okay, so remembering that, but you'll be given both of those depending on I'm not sure exactly what the formula sheet gives you, but you'll be able to identify them. It'll say it'll be a regression. Okay, so an example that they can give you. And this is an old exam paper question, I think from about 2 or 3 years ago. And it's going to look a lot like this, okay? So they're going to have age in years or income, and they generally have something along those lines. They will actually tell you the X and the Y. Now, remember in class, the X, if I can just go back here quickly, the X there, that's your independent variable, and Y is your dependent variable. What's the change? What's the difference? X drives Y. That's why once you know what X is, you're going to be able to solve for Y, okay, which is the second part of the question. So here you've got age in years, you've got income. X is your independent variable. It's driving what your income is, which is your Y. Okay, so X drives Y. And it'll give you some context. It'll say something like, this is the ages of a sample, etc., etc. And then they'll start. Determine the linear regression function for the data set. They could ask you for a best fit line as well. Whatever they ask you for, the first bit is that you need to find your A's and B's and fit them into your equation. Then they will come to the prediction part of it. And that's so once you've got this, you can then predict that. So the first foremost point for you to do when you're in the exam is to immediately write down your formula from your formula sheet. And once you've got this in front of you, class, and what I'm going to show you now, and I mean, I'm pretty sure you know this anyway, it's just a question of filling in numbers. And I'm going to say that again slowly. It's just a question of filling in numbers. This is not maths in the truest sense of the word. It's actually just substituting into a formula. Okay, so we were given this table. Okay, now you are going to need to fill in another 2 columns. Okay, so however you do it, you can put it in your exam paper, whatever, but you need this set of data at the bottom. I'm going through that again. This is critical for 2 reasons. Why? It's the numbers you're going to be putting into your formula. So you're substituting the numbers into your formula. That's number 1. And number 2, more importantly, your lecturer is going to mark this. Because let's be honest, class, we know that you all have calculators that can actually just find a best fit line. Your lecturer's probably gone through it with you as well, because it's a way of checking on your Casios. But if you don't show your workings, okay, you're not going to get the marks in this question. You say that very slowly. You must show your workings, please, class. Okay, so what do you need to do? You've been given that data. That was from your test paper, from your exam paper. Now you need to add another 2 columns onto this, okay? An x squared and an xy, okay? So your x squared is take your x and square it, multiply it by itself. Take each x and square it all the way down, okay? And then your xy is take your y or your x and multiply it by your y. X by y all the way down, and you're going to get those numbers there. Once you've done that, however you have done it, you then are going to put into your exam. You can actually do this in your exam paper, or you can just have a final little table thing at the bottom. But this is critically important. Do not leave it out, please. This is sum of y. So we're going to go and see. You'll see that you need that sigma y is sum of y. Sigma x is sum of x. Sigma xy is add up all your xy's and you got them there. And then sigma x squared is taking this and adding it up. So do you understand why it's important? You must evidence to your lecturer that you've done this calculation and you've got those 4 columns and those 4 numbers. Because those numbers, now it's a question of just filling in it's just paint by number basically. Because what we are going to do is we're going to use that formula and we're going to see what, first of all, we need to fill in. So always remember in statistics, N is your number of data points. N is the number of data points. So how many? 1, 2, 3, 4, 5, 6 data points. Okay, well, it's actually an ordered pair, but you've got 6 of them. Okay, so that's your N. The N can never change. So where you got an N on the top, a 6, then you're going to have a 6 on the bottom. So always count it. It's generally 6, but hey, who knows? Hey ho, they can give you 6, they can give you 5, they may even give you 7. Check before you just blindly put down a number. Then, once you've got that, then all you do, students, is you take the number. It says sigma xy. There, you've added those up and you whack it in there. Minus sigma x. There's sigma x, 256, multiplied by sigma y, 254. Remember that I've shown you here just brackets. That means multiplied, okay, as it is there. On the bottom, 6 again, data points or ordered pairs. Open brackets, x squared. Now, class, remember, this is really important because it'll come back to bite you as well in your ungrouped and grouped data if you're not careful. Sigma x squared without any brackets means the instruction to you is statistically take x, square it, and then add it up. Okay, all right. I'm making a point about this because this is not the same. So you take each x, you square it, and then you add it up. In other words, students, you're dealing with this number here, that number there, this number here, minus, then it says sigma x squared. And there's brackets there, class. And what that instruction is totally different from that instruction. This is saying take your x's, okay, add them up, then square them. This instruction is saying take your x, add it up. And they are two totally different numbers. Once you've got that and stuck it in, and all your calculators are algebraic functionality, your calculator can do that with a beat of an eyebrow. Okay, and then you get your B. Now, your B is your 0.71. That is your slope coefficient. Now you have got a B. Okay, we're not sticking it anywhere yet, but now we can put the B into here because that's what you need to do. So now we're going to the B, and now we need to calculate A. A, class, is our y-intercept. It has its uses, particularly when you're doing calculations, so we need to keep it there. So now what do? Now we go back to this calculation. Now, do you see how important this calculation is? You use these numbers in both B and A. And there are how many times I can't say, students, that I've seen students throw marks away by not doing this calculation correctly, carelessly, or just slipping up somewhere. If this is really important, because I'm not sure what the new mark scheme for this will be, but if you get these wrong here, you're going to carry it all the way through, and you've probably thrown, therefore, okay, so let me give you an example. So let's say you got this number wrong before we do the calc, and it's not 256, you made a mistake, and it's 236. Right, all of those numbers then are going to be wrong. So your lecturer is going to come and mark that. You got 3. Okay, there may be some method marking your lecturer may decide to do or not, as the case may be, but you're not going to get much more than 3 or 4 out of a potential 10 or 12. If you get these right, class, you're cruising for a 10 or a 15 straight. And I'm saying to you now, for those students who are on distinction territory, that's something you don't want to throw away. All right. So make sure you do that. Even if you go back and later check it on your calculator, check the numbers. Okay. Right, so now we're looking for A. We're going to take sigma y. Sigma y is 254 minus what we've just calculated, multiplied by sigma x, divided by 6, divided by n, is going to give you 12.04. Now you've got both. You've got A and B, apologies here, and you just stick it in. 12.04, which is your A, plus bx. Okay, now note, students, the x is left open. Why? Because you're going to use it to predict now. So, okay. So, yes, hang on a second. Do you want to say something, Kupisa, or do you want to make a chat? Do you want to put something in chat? Let's have a peep. Let me see. Sorry. I'm trying to... Okay, let me see. I'm looking at that. Let's just stop quickly while Ms. Jambela is asking something, and I can deal with it. Can't see the content. Please, class, I think most of you can. What I suggest, please, and this is, do it now quickly, log out and log back in again. Unless this is a general situation. I don't think it is a general situation. Nobody else has said anything, so I'm assuming that all other students can see. So please log out and log back in again. It'll help you. And then if there's a situation, I'm afraid I can't really do much at this stage, but if it's a general situation, then it's a problem. Okay, so please try that, and then we'll see we go from there. All right. Okay, class. So while Mr. Mbele is going to maybe log in and log out again, and hopefully see what's going on. We're just going to continue, and we're going to go very slowly. And what we're going to do now is we are going to look at the equation. You've got the equation, but you haven't got the x. Now that's what the thing you're needing to find. So let's have a look. So they will ask you in the question the prediction part. Okay, so the prediction part of the question is going to be here. And in this situation, if a female is 38 years, so when they give you that, that's your x. Okay, so now you're going to go and you're going to put in 38 there, which is your x. And then what we are going to do, we're then going to solve for it. And you're going to get 39.02. Now, class, another golden rule while I'm thinking about it. Places where students just, it's not because you got it wrong. And I'm pretty sure your lecturers have drilled this into you. Okay. But if, for instance, they come to you with this question. Now, please note this, class, and make a mental note. If your y is in thousands, okay, they will lop off the thousands because it's so much easier, excuse me, than dealing with 45,000, 51,000. All right, but you can't forget that because now you're not dealing in a thousand. So your final question, your answer is 39.02. But remembering, you need to reconvert it back to 1,000. Okay, so if your y is in 1,000, if your y column is in 1,000, check before you move on from this question. Reconvert it back, and therefore, in other words, just multiply this thing by 1,000, and then you will get to 39,020 on a prediction. Okay, so again, that's the second rule of thumb, please. If your y column is in 1,000s, class, make sure, please, that you reconvert it. But don't do it unless your y column's in 1,000. Otherwise, you're going to get a number that is meaningless. Okay, so keep that in the back of your minds as we move forward. Okay, so that was section A. Section A, again, is 3 questions. Chapter 1 of your book, which is all about random variables, etc. There's always a couple that pitch up often consistently. So what I'm going to say to you again before we move on is, what's the weakest form of data? What's the strongest form of data? What is qualitative data? And what kind of data is it? It's either nominal or ordinal. And remember, ordinal is ranking. And quantitative data, class, is either discrete or continuous. If they look and if they ask you a question and they say the number of cows in a field, class, immediately you know it's quant, the word number, and then you know it's a number, so it's quantitative, and it'll be discrete because you can't have half a cow. All right. If they talk about things such as marks or volume or something like that, that becomes continuous, okay, because you can fractionalize it. So remember those, they're very basic rules of thumb. They often crop up, and you'll probably have one of those matching tables where you have to know your definitions as well. So what's the difference between statistics and statistic? A statistic is one of a sample or a population. Statistics is the study of data. Okay, experimentation, all of those things. Remember, experimentation is when you are when you're using data to try and find an answer to something. So please go through that. Don't forget it. It's easy marks, but there are some basics. Okay, so moving forward, we're now looking at section B. Section B will most, I suspect, going to have either it'll have 2 questions, okay, of which you are going to answer one. The first question will be either ungrouped data or grouped data. Now, depending on which way you prefer your stats, sounds funny to say it, my suggestion to you is, if you don't like filling in formulae, then go the ungrouped data route. If you are happy with formulae, then either way, okay? Because this group data is all about filling in formulae. Ungrouped is all about, it's actually, in my opinion, okay, it's easier, all right, except for one thing which I'm going to cover with you. All right, so let's have a look. So we have got an ungrouped data example. What are they going to do? They're going to start off with a stream. How do we know it's ungrouped? Because it is one long line of data. Okay, one long line of data. It will hopefully be ranged for you. So it'll go from smallest to largest. Okay, smallest to largest. And generally they're ranged for you, but always check, please. Just check. But they're not generally not like that. They generally give it to you nicely ranged. Generally, again, class, they give it to you in an odd number, in either 11 or 13, but just check that. Okay, and then they're going to ask you questions around this sort of a situation. Calculate a mean, a first quartile or a third quartile, and if it's ungrouped data, class, it's going to ask you a standard deviation. I'm going to say that again slowly. If it's ungrouped data, because there's not much else they can ask you, they will ask you a standard deviation calculation. And when we get to it, this is what I need. You've got to be able to know this. Okay, they're going to give you the formula, but you've got to be able to know how to deal with that formula if you are going ungrouped data. All right, so let's move on. So ungrouped data example, there's the data stream. What is the mean? You're going to add all those data points up and divide by the number of data points. Okay, so sigma x, adding them all up, dividing by n, is going to give you 168.91 in this example. Okay, first quartile or third quartile, they're not going to give you second quartile because second quartile is basically the median value. So if they're going to ask you for a median, they'll ask you for a median. So they'll either give you first quartile or third quartile. Now, in this situation, class, where they're asking you for first quartile, so you are looking. So remember what quartiles are. It's this data, and it is blocked, or it's going to be chunked into 4 equal segments. Okay, we say that slowly, into 4 equal segments. What they are asking you to find here is the value of the first quartile position. Okay. Now, how are you going to do that? So if it's uneven, okay, I'm not going to do the counting bit. I'm going to give you a formula and let's do that. If it's first quartile, it'll be 0.25. Why? Because you are looking at data that is chunked into 25, 50, 75, and 100, or a full block. So the first quartile ends at the 25%. So you're going to use 0.25. You're going to open your bracket, n plus 1. N is the number of data points. Here there are 11 data points. So we're going to put 11 in there, and we add it, and we're going to plus 1, which is 12, multiplied by 0.25, which will give you your third position. If this was a third quartile, you would have 0.75 n plus 1, and that would give you the 9th position. Now, that's not the end of the story. That's the position. You need to find the value of the number occupying the third position, okay, in this case. So you're going to go 1, 2, 3, and it's 164. Done and dusted. So, and there'll possibly be an interpretation. Write something. Go and check what your lecturers have taught you. If it says interpret, then write something so you have something that your lecturer can mark. Okay, if they gave you third quartile, 0.75 n plus 1, it'll give you the 9th position, and then you'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, and you'll put in 175. Okay, not too difficult. So as I'm saying to you again, if they give it to you in this basis, go the ungrouped route. It can be a lot easier, and it'll give you time for whatever's lurking at the end of the paper. All right. Still on ungrouped data, class. Now I just want to spend a bit of time on variance and standard deviation. You will, without a shadow of a doubt, get a standard deviation calculation in ungrouped data. This is not me being clever. It's me saying to you that there's not a lot they can ask you. So it's a very good idea to understand and be able to deal with your variance and standard deviation formulae. So the first thing you're going to do is you will be given, I think there's 2 formulae. I think they give it to you in the back of your formula sheet. I don't know. Whichever one, class, you use this one. Okay, This is by far the easiest formula to use, particularly in the way that we're going to be looking at. Now look at it, it says sigma x squared minus n multiplied by x bar squared. Okay, so remembering our basic algebraic rules, when you've got something like n multiplied by that bar on the top means average. You've just worked it out, by the way, in the previous example, in the previous example there. So what do you need to do? Now, again, it's a stats 101. You're now going to find the numbers and you're going to plug them in. The crucial issue here, class, this is a crucial issue, that sigma x squared, it is not take x, add it up, then square it. That is the most common mistake in your standard deviation calculation. All right. If there's any mistake that a student makes, it's saying, okay, let me take my x's, add them up, and then square it. No, you're not going to do that. You are going to take each x, then yellow, there, those are your x, that's your basic range. You take each x, you square it. Each x, you square it. Okay, you got the message. This green is x squared. Then, class, and only then do you add it. That then goes in there. All right. So that's this calculation here goes in there. Minus n. How many data points have you got? 11. You count them again. Open bracket. What's it telling you to do? Take your x bar, your average. What was your average? 168.91. 168.91. And then because of Excel, you got a little copy, which means exponent, raising it, squaring it. Now, how do you go about this section of the calculation? Well, the first thing you do, students, is you take 16891 and you immediately square it. Then you multiply it by 11. Please, on no planet do you take 11, multiply it, then square it. Okay, because this squaring is for that. If it was for all of it, it would have brackets around it. Okay, so remember your basic algebraic rules. On the bottom is n minus 1, which is 11. Minus 1 gives you 10. Get the calc, do the calc, 94.35 in this example. That's not your standard deviation. Hey, remember, that's your variance. Now you'll finally take the square root of your variance and you get your standard deviation 9.71. Generally, they don't ask you to interpret it, so just be gentle there. Here, they would ask for interpretation. So always remember, write something down. Okay, and that's the worst they can throw at you in an ungrouped data question. Okay, so they could ask for mean, they can ask for medians, they can ask for first and third quartile, and they can ask you for a my suggestion to you is they will ask you for a standard deviation. Okay. All right, so if you're going the route, and I suggest to my own students, make up your mind now which way you're going, so you don't sit and hum and ha in the middle of an exam. You immediately know you're going to do a question 3. It's ungrouped, get going with it. Okay. Remembering as well, you can't answer question 3 and bits out of question 4 and hope that your lecturer is going to mark the bit out of question 3 and the bit out of question 4. We can't, it's not allowed. So you will be either marked on question 3 or question 4. All right. Now, moving forward, there will be at the end of the ungrouped data, there will be a question on either a bar chart or a pie chart. Okay, you guys know how to do that. I'm pretty sure your lecturers probably drummed it into you. The most important things to remember: title. Remember, it'll probably be for 3 or maybe even 5 marks, and you can whack a 5 mark very quickly. But remember your basics: having a title, put in your numbers on your x and your y axis. Please label your x and y axis efficiently. Put in your title, and please, 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 if it's a bar chart, do make sure that the bars do not touch. Okay, let me say that slowly. The bars do not touch. If they do, you'll get the thing fully wrong, and it's called a histogram, actually. Also, perhaps, as a nice addition, is, I haven't got it here, put in a number on the top, whether it's either the number or the cumulative the percent. Either way, they'll ask you in the question, put it on the top so that your lecturer can read it. And when you are dealing with a bar chart, please don't start the first bar on the axis. Pull it in just a little bit. Always remember to put on the bottom the legend for whatever companies or whatever you're looking at. Done and dusted. Very easy. The only other thing they could ask you for is a pie chart. And a pie chart you all know how to do. If this was a pie chart class, that you would take that data, I would suspect most of the time it's going to be percentage frequency, get your percentages out, and then just divide up your pie by giving, like, for instance, this would be over half the pie would be PNP, etc. Just make sure that you don't have to go and sit and do it scientifically, but just make sure that the sections of the pie do kind of correspond to the numbers that you are calculating. So it'll either be bar or pie. Check what they're asking for. I've seen students throw away marks because they didn't look. They just assumed it was a bar chart, and actually they were asking for a pie chart. Okay, so that's ungroup data. We're still in section B, and now I'm just going to quickly deal with group data. All right, so moving on. There, if it's group data that you are deciding to do, then you know that you're going to be given a frequency table, cumulative frequency table, or not. They won't give you the cumulative column generally. They're going to give you time, and they're going to give you frequency, or whatever the context is. They will give you the intervals. Generally, you'll have 5, and they'll give you the frequencies. Now, generally, class, they will ask you probably 2 or 3 types of questions on this data. I'm showing you the median and the mode. They could also ask you either a first or a third quartile. Very infrequently do they ask you for a standard deviation. So for us today, I'm not saying, please, if you're going to go the grouped route, also revise the standard deviation, but it is a fair whack of work. And generally, they ask you means, medians, and first or third quartile. I'm going to start with the median, and then I'm just going to move through to the modal values and then show you quickly those types of calculations. Right, so let's have a look at median. They will give you your median formula. It's always a horrific looking formula, but it's actually fairly simple when you know the basics. And I'm sure, as I've said, your lecturer has given you the basics on this. But let's just go back to what they will give you this column and that column. Very infrequently, in fact, not at all, do they give you a cumulative column. Now, the cumulative column is vitally important for your median calculation, your first and your third quartile calculations. So if you are doing group data and you are going to be, generally they will be looking at medians or first and third quartiles. You need this column, and I'll explain why now. So because otherwise you can't identify the median interval without this. Okay, so let's see what I mean as we move forward. So your formula is basically your lower limit of the median interval, and then plus, and then you keep away from this until you've calculated this, then you add it to that. You never bring this in until you've done all of that. And then it's C n over 2 minus the frequency of all the preceding intervals, etc., divided by the frequency of the median interval. Do you see all of these? There and there, you've got to identify the median interval. Now, if you have not done a cumulative column, you can't identify a median interval. So the next big question is, how the heck do I identify a median column? This is the important point now, class, for you to remember. Depending on the frequency total, it could be 30, it could be 50, it could be 60, okay? It could be 75, it could be 100. I have no idea, but you need this number to identify the median interval, okay? You're going to need that, and you need the cumulative column. So the first thing you're going to do if you're doing group data and you're looking at a median calculation is you spot what your n is. If they don't give it to you, jolly well add it up, okay? Most of the time they give you n, sometimes they don't. So be prepared to look for n. You got 30. Now you're looking for a median value, class. So you take your 30, and median means the middle. Median means the middle, okay? Median. So what is a median position of 30 data points? It's number 15. That's not the value, that's the position. So now what do we need to do? We need now to go to our cumulative column and find out where 15 falls in, because then wherever 15 falls into the interval, that becomes your median interval. Okay, so does 15 fall? This is now, remember, this is data points. This is the number of data points in each interval. There are 3 data points in there, 8 in there. So is there, well, not 8 in there, sorry, cumulatively 8. Apologies. So there's 3 in there, 5 in there, 9 in there. So this is cumulative. So 3 plus 5 is 8. So does 15 fall there? Nope. Does 15 fall there? Nope. Does it fall in the next one? 8 plus 9 is 17. Yes, it does. So that's the 17th data point, and 15th data point falls between 8 and 17. Therefore, class, this becomes your median interval. Your median interval, not a value, an interval. Now, with that, you can now move and you can start your calculation, because now you can say to yourself, right, what's the lower limit of my median interval? There's my median interval. 30 is my lower limit there. So that goes to 30 there and there. Next question, plus C. C is always going to be your interval width. Here it's 10, class. I know it says 10 to just under 20, but hey, don't get clever, make it 10. If it was 10 to 15, it would be 5. If it was 10 to 12, it would be 2. Generally, they give you a frequency interval or gap here of 10 or 5. Okay, count it, make sure you look what it is. Don't take it for granted. But here we got 10, so that's where the 10 comes in there. See, n divided by 2, that 15, class, is always the number you are using when you're finding your median interval. If you get a different number there from the number you wanted to plug in there, then you've made a mistake somewhere, okay? It has to be the same, because remember the calculation. 30 divided by 2, because it's a median value, so 30 divided by 2, all right, gives you 15. Gives you 15 where you're finding it there. So 15 minus, now this is the only thing that may catch you out, the frequency of all the preceding intervals, but not including the median interval. Okay, so of all the ones below this one, and of course the frequency is, hey, you can count it, 3 plus 5 is 8, or you can just look at that number there. That is your 8. If your number here, class, is greater than that number there, then you've made a mistake. You've actually included your median interval. So you can't get a minus here. You can't, okay? So if you get a minus here, you've made a mistake, okay? So even before you move on. But in this situation, we haven't. So we got 15 minus 8 multiplied by 10 divided by 9, added to 30, you get to 37.78. Here is another rule of thumb while you're doing it for those who are doing group data. This number here, the median number, must, class, fall in the median interval. So if this number here was 42 or 25, you have made a mistake somewhere. And that's the time to go back and try and check it. Okay, so again, remember, in section B, ungrouped hasn't got all of this. But for those of you who feel comfortable with these calcs, actually, class, it can actually go quicker than even your ungrouped. But each one of you out there knows which one you feel more comfortable with. My own suggestion is ungrouped, but that's a particularly personal view. Okay, each one of you knows. All right, so that's your median values. Moving on to modal. Oh, and by the way, let's move back quickly. If this was a third quartile or a first quartile, it would use exactly the same formula, except in a first quartile, you wouldn't have n divided by 2, you would have n divided by 4. And in a third quartile, you would have 3n divided by 4. Okay, all right, because that would be 0, or to cut it out, 0.25, 0.5, being multiplied by n, or 0.75 being multiplied by n. What we've done here is, because it's median, is 0.5 multiplied by n, which is 0.5 multiplied by 30 gives you 15. All right, class. So if this was first and third quartile, Let's pretend it was first quartile. I'm not going to do the calc. I'm just showing you that you would then have 0.25 multiplied by n. So you take 0.25, take your n, 30, multiply it, find where that falls in, and away you go with exactly the same type of calculation. That's not difficult at all. If you know your median values, you can median calculation and processes, you can easily do first and third quartiles. Okay, modal value is different, but actually really easy. Here, you don't need your cumulative column. All you need to say to yourself, students, is here. So we take away, you can pretend not to see it. You don't need it. But what you do need here, class, is a frequency. You need to run your eye down the frequency column and see which is the interval which has the biggest numbers, or the biggest number. Okay, in other words, the interval with the highest frequency. And that becomes your modal frequency, first and foremost, done and dusted. So you can do that in the space of about 3 seconds. And in this case, well, I'm using the same data set, so it'll be 9. Why? It's the biggest number. It's bigger than any of those that you can see there. That becomes your modal, interval. Right, now you've got 9, so there again, it's 30 to just under 40. Now what we are going to do, so therefore the lower limit in the calculation, and I mean in the formula, they're going to give you that formula. There's the lower limit of the modal interval, which is 30. So we stick 30 in there. I think I may have done it here. Here we go. Nice and clean and fresh. That's 30. Then we've got C again. C is 10. It was using the same set of data. Then these are just frequencies. In other words, the number of data points in each of those intervals. So C and then open bracket FM, frequency of that modal interval. So you now go back. Sorry, I'm just going to do this. There's your modal interval. There it is as 9. So that is 9 there. And then the frequency of the M minus 1 is the preceding interval. So that's 9 minus 5. Again, logically, class, you can't have a minus here, because you've identified this one as having the highest frequency. Therefore, none of the others can be larger than that. If they're larger than that, you've made a mistake. Okay, so 9 minus 5. And then we move to the bottom. Be just one careful, just be cautious here. That 2FM deals just with that. It just deals with the 9. It does not deal with the rest of it. Okay, so please remember that. So we've got 2 times 9 is 18 minus the preceding interval and minus the 1 plus 1 is the one after it. So in other words, there's preceding, which is M minus 1. This is M plus 1. Okay, once you've got that sorted out, do the calc, get the number, 36.67. Follow your rule of thumb, students. Does it fall into the median, to the modal interval? Yes, it does. Therefore, it's very likely that I've got this right. Okay, all right, so that's ungrouped, that's group data. Apologies, they can only, or I suggest they would probably ask you mean, median, and either first or third quartile. If you're going to do this class, my suggestion is do some exercises on it. Just make sure you know what you're doing. You've got the formulae in the exam. Just remember what you need to look for. So with your median, your first and third quartile class, always remember you're going to use that cumulative column. You must have a cumulative column. Modal, you're just looking for the highest, the interval with the highest frequency. Okay, so that's where we are. The last thing they can ask you here, so with ungrouped data, they'll ask you for a bar or a pie chart. In your group data, they'll ask you to draw up a cumulative frequency table. So they will give you a bunch of data it's probably going to be something like a 4x5 matrix of data. In other words, a block of numbers, and then they will tell you the interval width and you'll need to draw it up. Personally, class, there's a lot of work in that, all right? More so than drawing up a bar or pie chart, but again, I'm leaving it to you, all right? It's not difficult, and if you're going the group data route, just go and practice that. Drawing up a frequency contingency table. Okay, right. They sometimes when you are dealing most notably with ungrouped data, they could ask you for a coefficient of variation. Often they do. And what that is, so that's with ungrouped data, not group data. Generally, then you'll have worked out the standard deviation in your ungrouped data. You'll have worked out the mean, and you divide your mean into your standard deviation. So and the higher the CV, the greater the variability of data. That's all you need to remember. The other thing they can ask you, which I don't think I've dealt with here, but I'm just reminding you, class, is the skewness of the data. And you're just going to, in other words, use the calculation that they've given you in your formula sheet. And this is rule of thumb, okay, for skewness of data. If the number's not minus, it's negatively skewed. If it comes out positive, you just say it's positively skewed. That's as much as you really need to do in terms of interpretation. Right, so that brings us through section A and section B. Now what I'm going to do with you is I'm going to start with some probabilities. Now I'm going to deal with the two main probability questions they can ask you. Okay, one of them is going to be calculating marginal multiplication, addition, or conditional type, or they can ask you for a probability tree. Okay, they can ask you for either of those. Generally, they don't give them together. So I'm going to go through both kinds of processes with you now again. You can root around on this YouTube video on the channel, because I went through it fairly rigorously in the last masterclass, but I'm going to do it again now. And then the other things they can ask you for are permutations and combinations. Those are pretty simple. I'm not going to deal with those. I'm just reminding you of them. Okay, so the concepts they are going to discuss, class, or they're going to examine you on, are going to be 5 of them. Generally, they're going to look at 4 out of 5. So you've got these probability concepts. One of them is called a marginal or a single probability. So if I give you a bag of marbles and I tell you there's 20 marbles in there, 10 are green, 10 are blue, what's your probability of pulling out a green one? That's a so-called marginal or a single probability. It's a single event, class. You put your hand in, hey, if I pull out a blue one, it's 50%. If I pull out a green one, it's 50%. So that's your first most simple probability. The second one is addition. So you've got 2, and you're only going to ever deal with 2 events. All right, so you've got 2 events and you need to know how to add them, okay? Or you've got 2 events and you just want to find what's in the middle, so what the joint probability is. So this one is adding all the probabilities up, and this one is finding what the one in the middle is. This one is conditional. Now it looks horribly and complementarity. So there's 5 of them. Generally, they are going to ask you marginal, addition, joint, and actually they're marginal, intersection, conditional, and complement. I'm going to go through all of them, but they generally give you 4 out of 5. If they start, or if this is what they're going to give you, it'll be in section C. All right, and section C will have 2 questions. One of them will have probabilities, and the other one will have probability distributions, okay, the binomial Poisson. I'm going to spend more time on this because this is, I think, most students tend to go this route. Not because binomial Poisson's bad or difficult, it's just that most students, I think, feel more familiar with it. All right. So they're going to give you a table like that, okay? And they're going to say generally males, females, and then something at the top. Here we got shops, could be magazines, it could be laptops, it could be whatever. Okay, then they're going to give you a set of questions, and let's read them very briefly. Then I'm going to show you how to answer them. Okay, a female respondent from the samples. That's exactly the same as if I gave you a bag of marbles and pull somebody out if it's random. That's a single. Okay, then you're going to have some keywords which are important. A respondent who is male and prefers Woolworths. A female given or and does not prefer. These, class, are critical. Let me say that again slowly. They are keywords and they are critical because each one of them gives you the indication of the calculation you need to do. Okay, so when you are dealing with who is male and prefers, you're dealing with a union. All right, and I think I may have put it here. This is one of these, not union, it's intersection. So each one of those, as we go through it, I'm going to show you how we do the calculation. Now, class, there's 2 ways of doing this calculation. I'm sure your lecturers have done both. I personally use an eyeball approach, but you're welcome to use a formula approach. Okay, I'm giving you both approaches. I'm going to show you they both work out. But for me, and the way I've taught my students, is the so-called eyeball approach actually works, and it helps you through this. So let's start with each of those types of questions they can give you. So the first one is generally they're going to give you is a single or a marginal probability and a female respondent from the sample. So what's the sample size? It is 400. Okay, you can see there. You add those up there, it's 400. So it's pretending as if you had a bag of 400 people and you have got 275 that are males and 125 are females. What is the probability of randomly selecting a female? Well, it's going to be 125 over 400, which is 31.25. Take it to 2 decimal points, class. Take it to 2 decimal points, please. All right. Done and dusted. That's it. So that's as easy, and that's what a mark or two done. All right. So the next question, let's take the next one. Calculating intersections. So there's my eyeball method and there's my formula method. All right, class, you're going to have this loaded onto YouTube anyway. I'm not going to go too much through the formula method at the moment. It's in your book. I'm just showing you that the two numbers come out exactly right. But what I want you to understand is the way that they phrase the question is the way that you know how to answer it. So calculating an intersection, that is the word, the key word, class, is and. All right, and, not given or, it's and. So a male and prefers Woolworths. As soon as you see that word and, you know it's an intersection. And the best and easiest way for me to teach, I'm not dumbing this down, but I'm telling you the rule of thumb is saying, right, an intersection. Now think about what an intersection is in the street. It's one road coming in and another road coming in and they meet in the middle. Oh, well, they don't meet, but you have an intersection. Okay. So that's exactly what you're going to do with this data. There's your males, okay, and you are going to intersect it with Woolworths. So there's males intersected with Woolworths, and it's 125. What is your total? 400, 31.25. If they said female and checkers, you're going to go female checkers 50 divided by 400. Okay, I think you kind of get the point. And then you just make sure it's to 2 decimal points. There we go. It's as simple as that. If you want to do the formula method, for those of you who do or correctly want to go into it, here we Storm, actually, no, I have not yet seen a memo which says you actually have to do it like this. So I'm going to say I'm going to take a leap of faith. And I'm going to say, class, I know, and I'm telling you this now, and it's going on to that for my students, I use either eyeball or formula. I'm perfectly happy. Providing they get their answer, your lecturer should be happy, okay? Because the memo itself, by the way, generally doesn't distinguish between the two methods. All right, so go and do, yeah, I would say do it. Okay, if there's a problem, then come to me. I will deal with it. Okay, so there's eyeball. Okay, all right. And it's so much easier. It really is just so much easier. Okay, so that's your eyeball, who is male and prefers. So the and is intersection. And is intersection. Next one down. What is the probability of randomly selecting a respondent who does not? Does not. So we had and in the previous one. Does not. That's complement. Okay, in other words, it's the people. So you've got probability is sums to 1 or 100%. So if you say it's the probability of it raining today is 30%, the probability of it not raining today is 70%, or 1 minus 30%. That's complement rule. Okay. So in this situation, a respondent who does not prefer checkers. So it's everybody else who except the people who don't like checkers. So now you have two approaches. You can say to yourself, like I've just given you that example of rain, what is the probability of someone liking checkers? That's 110 divided by 400, okay? And then 1 minus that means it's the other two. Or if you really want to do the long route, and it won't matter, you can take the probability of that. So 150 over 400 plus the probability of 140 over 400 and add them together. It has because this is a collectively exhaustive process, they're going to be the same. Personally, in a situation like this, I would go whatever they're looking at. So a respondent who does not prefer checkers, 1 minus the probability of checkers. Okay, so 110 over 400. Or a respondent who does not prefer Woolworths. So 140 over 400, 1 minus 140 over 400. Take it to 2 decimal points. So we've learned so far marginal. we've learned that intersection has the keyword and the complement question has does not. Okay, those are the keywords. Oh, heck. And then finally, I haven't, I should have, oh, apologies, class, I missed out a one here. What is a probability? So you got a conditional and addition. I'm not going to deal with addition at this stage. I'm just going to deal with conditional. So in our minds, we've got marginal, which is a single. We've got complement, which has the keyword does not. We've got intersection, which has the keyword and we have got the final one, which I'm going to look at, is the word given. So the keyword is given. Okay, like I said, for and was intersection, given is conditional, class. Okay, so that is our conditional keyword. So if the sentence has conditional, I mean given in it, it's a conditional. It's a conditional question. Right, now there's the this is unfortunately one of the few ones where you can use a formula if you want to, but I'm going to show you how not to, and then I'm going to show you the formula. Okay, so in a conditional question, conditional is the only calculation, and this is important. If you remember this, then you're set for life. Conditional is the only calculation where your denominator is not going to be the total cohort. Okay, let me say that again slowly. It's not going to be 400. It's going to be your so-called second identifier. So what do I mean? It says a female respondent given that the preferred supermarket is Checkers. Now just see what the word is, what the question's saying. What is the probability of a female like that being pulled out of the slot who likes Checkers? So naturally, you're not going to use the full cohort. You're just going to use the Checkers cohort. So in this situation, you've got female, Checkers, 50 over 110, not 50 over 400. If it was 50 over 400, it would be an intersection with an and. It is not an intersection question. It is a given question. So we do not have 400. We have only the total of the second identifier. So if it was a male, given that the preferred supermarket is Woolworths, you would go along male Woolworths 125 divided by 140. If it said male Pick and Pay 90 divided by 150. If it says male and they like Pick and Pay, then it's 90 divided by 400. Okay, I think and I'm not trying to dumb it down. These are rules of thumb that are going to help you get through it. Okay. I'm not going to worry about addition at this stage. I want to get on to the second type of question that you need or will be asked to answer. So they can give you that I've just gone through, or they can give you a probability tree. If they give you a probability tree class, it's going to have a question very similar to this one that I've got out in front of me. A bag contains 9 green and 11 blue marbles. You're asked to select 2 marbles from the bag. The first marble selected will not be placed back into the bag. Okay, lekker. So now we're starting. Construct a probability tree showing all outcomes and what is the probability of selecting 2 blue marbles. Okay, class. Then before we even start, what are we going to do? We're going to construct this thing to start with. So you're going to start with 2 branches. One arrow going up, one arrow going down, and then the second branch, another arrow going up, down, another arrow going up, down, because there are 2 events. Okay. All right. The 2 events are you are asked to select 2 marbles in a consecutive order. So the very first set of marbles you're going to take, you've got, first of all, the very first thing you do is you take 9 and add it to 11. Okay. So you've got 20 marbles in total. So your first selection process is, okay, do I take, you got your bag of marbles in front of you, and put your hand in. Okay, so I'm going to go through this as if this is the question. And you put your, and it's good for you to visualize it. You put your hand in. So you've got 9 green and 11 blue. Put your hand in and you pull out a green marble. That's the probability of pulling out a green marble. Hey, that on its own is a marginal or a single probability, 9 out of 20. Or put your hand in and pull out a blue one. That's 11 out of 20. Now, think about this now, class. The first marble selected will not be placed, or will not be put back into the bag. So now let's pretend we're working on the green marble. So you've all got this bag of marbles in front of you. You put your hand in, you take out a green one. You put it to the side. You do not put it back in the bag. So two things have happened here, class. You don't have 20 marbles in that bag now. You only have 19 marbles in that bag. You have not put that green marble back. And if you have taken a green marble out, class, you don't have 9 left. You only have 8. Okay, so that's where the 8 comes from. And you have 8 out of 19 for that second leg. You haven't touched the blue marble, so you still got 11 blue marbles, but now remember, the green one is sitting out, so now you only have a total of 19 marbles. That's on that leg. Now let's go down and pretend we start again, okay, from scratch. You put your hand in, you take out a blue marble. Great. Now, again, two things have happened. One, you don't have 20 marbles in your bag, you only have 19. And two, this time, class, you don't have 11 blue, you have 10, because the blue one's sitting on the side. So now what do? Is we now have got this set of probabilities. 8 out of 19 with the green one, or 11 of 19. Note, class, make sure you understand this, that you've got one less, and the top, the numerators must sum to the bottom. So 8 plus 11 is 19. 9 plus 10 is 19. Okay, so the first things to remember, rule of thumb, is you start with 20. Well, I mean, if it's 20, okay? If it's something else, it'll be that. Minus 1 to get to because you kept 1 out. It's not placed back. And then depending on what the colors are. That's the first thing. So that's this. And what they're going to ask you to do is these are independent events. What do I mean by an independent event? Because the marble has no memory. If it's very much like flipping a coin. If you flip 2 coins, let's say you've got two, you flip a coin twice. It's head or tails, and then it'll be head or tails again. But the coin doesn't know that it flipped a head the last time. So you could easily have 2 heads in a row. And the probabilities of that, therefore, are independent. It's the same with these. And how do you deal with independent events? You multiply them together. Okay, so you're going to take 9 over 20 multiplied by 8 over 19, and that's your first probability, equals 9 over 20 multiplied by 11 over 19 equals 11 over 20 multiplied by 9 over 19, and similar. Those are your 4. And by the way, if you want to check that they sum to 1, it's a collectively exhaustive event. All of those probabilities need to sum to 1. Okay, then that helps you answering the second question. And the second question is, what's the probability of selecting 2 blue marbles? Now you can see it. You can read off the jolly thing. There's a blue marble, and there's a blue marble. So it'll be that answer there. Most of the time, class, they ask you what is the probability of selecting a green and a blue, or marbles of a different color. So then you take these two inner branches, green and blue and green, and you use those 2 probabilities. These are really simple. So best try and just do some exercise on them. I'm sure your lecturers have done it, but it'll be either this or one of those contingency tables, all right, which are going to be your main questions. And then, of course, they can ask you your combinations or permutations, but they're not difficult. Just remember your formulae that you need for them. Remember, class, with a combination, order does not matter. And with a permutation, they will say to you in the question, there are 10 teams, and you are going to choose I don't know, 3 teams, and what is the probability of finding them in the correct order? That's a permutation. If they say to you there are 10 teams, what's the probability of correctly identifying 3? Then without the order, that becomes a combination. All right, here are the answers to this. So we've got 11 over 20 times 10. We've got 28.95%. All righty. So that's the end of our section B. Now, in section B as well, you could have a second set of questions, which would be binomial or Poisson, But class, I'm asking you now, because of limitations, and I want to spend some time on hypothesis testing, I'm going to ask you to go back into that masterclass and have a look at that, because I did deal with those. What I am going to deal with now in terms of probability distributions is critical for hypothesis testing. So here we need to find a probability using a standard normal distribution. So there's a step. So now we've got to click our minds into we're using or finding continuous data, and we need to find using a Z table the probabilities, because that class is where we need, when we've got this process sorted, we can then go across to hypothesis testing and be able to understand how we find those numbers that we need. Okay, so there's three parts to this. We convert an X value, so we standardize it. We convert an X to a Z value, okay, using the standardization formula. Now remembering, please, and this is an incredibly important point, that this is not what you use for hypothesis testing. This is not a sample. This is not for a sample. This is kind of right for a population with a, and I'm going to make that point and I'll show it to you again, with a sample distribution. This will be standard deviation divided by the square root of n for a particular calculation. But I'm just showing the process. You get your X, go to Z. Take that value here and go find it from your Z table. That's where you're doing. Your Z table is going to give you your probabilities. So for instance, the score obtained on an IQ test is normally distributed. They must tell you it's normally distributed. And with an average score of 115 and a standard deviation of, so those are your X values. What is the probability that a randomly selected person will obtain a score between 110 and 118? Right, so those are your X values. Now remember the process. X to Z, Z to table. Okay, so let's go and have a look. X to Z. So what we did there is we've used our standardization formula. And remember what that is. That is X minus your average they gave you. The average was 115. And the very first X will be 118. Okay, so 118 minus 115 divided by your standard deviation gives you a Z value of 0.32. And then the other one, because it's on both sides of your mean, it'll be 110 minus 115, which is minus 0.53. For your Z tables, you just drop the minus, because remember your curve is fully symmetrical about the mean. So whatever the number is here, if it'll just be minus and plus, it doesn't matter at all. This is because we're using a standard normal distribution. So we got those two values, class, and what are we going to do with them? So we go on to X to Z, X's to Z. Now we got two Z values. They are going to be converted into probabilities by going to our Z tables. Okay, those are the ones in the back of the book. Those are the ones that you are going to be given in your exam. You're going to have three sets of tables there. You're going to have a Z table, a T table, and a chi-test table. So as I said to you right at the beginning of this, what you need to do, as soon as you get in that exam room, and you're allowed to start, okay, not before, you take those tables and you take them off. Put them beside you, because you're going to be using them, okay, and along with the formula sheet. So we go to the Z table. You can do it when after this, and it's loaded onto YouTube. You can go back and go and have a look. Use those 0.32. 0.32 converts to a probability of 12.55 or 0.1255. That's just decimalized. And 0.53 converts to a probability of 20.19 or 0.2019. You're going to now, and just because this happens to be a question where your values are on either side of your mean, you want to find the full probability. That's a probability. That's a probability. You want to find it between the two lines. You're going to add it up. And I'm sure your lecturer has taught you the way around these issues. Okay. I'm unfortunately, I just don't have the time to spend. It would take another 2 hours just to go through that. But at least you understand. You go from X to Z, Z to table. Now, I want you to keep that in your mind, class, because we're going to look at sampling distributions. These are important because the sampling distributions, class, are going to be the way we deal with the hypothesis testing. All right, so sampling distributions, my apologies, I went through. So you're going to you could have one of two questions, okay? in your question. So let's go back. We've got section B, which is group to non-group. Section C will be the probability or probability tree or frequency table, or it could be a binomial or Poisson or a sampling distribution question. Most students are going to, perhaps I suspect, going either probability tree or frequency table with combination or permutation thrown in. Some students are going to go this route, but this is not the reason I'm doing it. These formulae here are what you're going to be using in your hypothesis testing. So you may remember the formula I just gave you was x minus mu all over sigma. It didn't have this bit here. This is the critical issue when you're dealing with a sampling, okay? This is really important. Don't use your standard formula with just a standard deviation. You've got to include this bit at the bottom, and I'll come back to that again in hypothesis testing. So you've got two types of questions in a sampling distribution. Both of these types of questions you are going to deal with in hypothesis testing. All right, so that's the best way to look at it. Is look very briefly at a question. So Class Act Pty Limited has found that 35% of its policyholders. Now, class, I want you to make a mental note again. A sample mean is a question which has a number, okay? And I'm going to come back to this in hypothesis testing. A sample proportion is dealing with categorical data, which is stuff which are like people or policyholders or clients. So the way that the question is phrased is that it has a percent. So if the question has got a percent, it is a proportion. If the question has got a number, it is a mean. Okay, mean, number, proportion, percent. So I want you to hold that in the back of your mind, because in this question here, we have 35% of policyholders. Policyholders are categorical data. Okay, and you're using a 35%. You therefore are using this formula. Remember, this one. It's got a proportion involved in it. It's got a percent. Now, all you do, class, is you are going to, because it's a sample, remember, we need to, this thing at the bottom here is called the standard error of the sample. So when they break up the question like that, all they're asking you to do is to calculate this thing first and then put it into the main calculation. So that thing at the bottom, the standard error class, is this here is the standard error. Similarly, so that's the standard error. The denominator is the standard error, okay, for numbers and for proportions. So when they ask you, as they've done here, to determine the standard error, you'd work with the denominator first, and you get 0.4. You can go through it a little bit later and just do the numbers yourself. But I need to get to how we get to the final answer. So there's your 0.04, which is your standard error for a proportion type question. Calculate it out, and you get that number. Now, what's this number here? Remember, x to z, z to table. So what this is all doing here, all of this calculation is going from x to z, and then we're going to then take it and put it into, we go to our z table. 0.25, go to your table, and you will find that you're going to find the z value that relates to that, which is going to be here. All right, so class, I just need you to remember that in your back of your mind, because now I'm going to because that's kind of section C. Okay, section C is going to be probability trees, probability contingency tables, or probability distributions. Now this is the one that we need to spend a bit of time on. That's why I know I said 2 hours, and I apologize for not giving you a break, but I'd rather just hit it one shot, because I want to spend probably about 20 minutes on hypothesis testing, and then I'm also well aware that you guys have got other stuff to do, so I don't want to waste your time. This is the section, class. It's going to be section D in your paper. It'll be 20 marks, and it's going to have 2 questions, of which you are going to choose one. Right. And the first question, which I suspect will be question 8, will be a hypothesis testing question. The reason, and they both of these ones, both 8 and 9, are hypothesis testing, but 8 is going to be using numerical or qualitative data, and question 9 is going to be a chi-test. There are two different approaches because the chi-test is categorical data. It uses a different underlying distribution. Most students, again, this actually is an interesting one because a lot of students are totally they're half. Some of them will do a question 8, some of them will do a question 9. Remember, you can't do both, depending on how they feel. Now, I teach my students that a question 8, and there'll be 2 questions in it, probably for 10 marks each, for 20 marks, and question 9 will have 2 questions in it, probably 10 marks for the 20 marks, okay? That if you're doing hypothesis testing, which is a question 8, then you must understand the process, because you need to be able to identify the type of question that you're dealing with. Once you've got the process sorted out, the calculations are actually very simple. If you don't understand process, then you're going to do a chi-test, which is a question 9, which is a lot simpler to identify, but there's a lot more calculation involved. Okay, so it's your call. And I'm going to do both of them now with you. I'm going to give you examples of both of them. All right, so let's do this. Class, this is useful. It is an organogram of decision making for a hypothesis question. If you are dealing with numbers, you're going to go on this side. Okay, this is a numbers side. And if you're dealing with a proportion, now remember I've just said to you, a proportion is categorical data, and it has got percents in it, you're going to go on this side. Class, you'll be able to, as I said, pull this off again. So you can, I strongly suggest, when you have a chance to on YouTube, just take this. I don't know if you can print it or at least take a snapshot, even take a photo of it now. It's really, really useful, because I'm going to use it now as we identify the types of questions that we can use. I haven't seen it in the book, and it does help you make a really quick decision about what type of, where and how you are going to identify the question. So the question is at the top. If it's got a number in it, you go this way to either that branch or that branch. If it's got a proportion or a percent, you go here. All right, so that's the big critical issue. You've got to get that right. Once you've got that right, class, then we move on. Okay, so let's just, oh, sorry, my mouse is starting to. Okay, so you've got that organogram or flow statement in front of you. Now there's a testing process. This is straight out of your book. There's 5 steps generally. I give my students 4 because I think you can telescope the last 2 easily into step 4. So what you're going to do is you're going to define a hypothesis, you're going to determine a so-called region of acceptance, you're going to calculate a test stat, and then you are going to come to a conclusion, basically. This is conclusions. What you need to do is you've got to identify the question first. So let's take an example that I've given you here. A simple random sample of 10 people from a certain population has a mean age of 27. The manager of the project claims that the mean age is 30. Now, first of all, before we do anything else, class, I'm going to show you the decision root of this, okay? There's the decision root, and I'm going to explain it to you as we go through it. Okay, so I'm going to go back to the question, and it has got numbers. It's not got percent, so it is going to be either a T or a Z test with a sample mean. Okay, it's got numbers, a sample of 10 people. There's no percents in this at all. Okay, so we are going this side of our flow statement. It's a population mean. Now, the next big question you must ask yourself is, how big is that sample? Okay, how many people did they test? Now, class, this is critically important, because if this number, I'm going to really slow down here now, if this number is larger than 40, you're going to use a Z test. If this number is less than 40, you're going to use a T test. Now, class, heads up. Generally, they ask you to look or to calculate a T test. They generally ask you to do a T test. So check what the sample size is. Okay. It's critical. So now you've seen that it's a number and that the sample size is less than 40. Okay, so we now go there and we now use a t-test. Look what I've written here. Population standard deviation unknown, and n, the sample size, is less than 40. If you know this, then you know you're going to calculate that. Right, so now we know the formulae we are using. Once we know that, it becomes just simply a matter of filling in the steps. So step one, define the hypothesis. Okay, so it's 4 steps that we are asked to do. Class, I'm suggesting you use the steps that I've given you, and I'm sure your lecturers have done it. So use it. Say step 1, tell your lecturer where you are. Remember, your hypothesis is a null and an alternative. Please write it like this. If it is a sample mean, it's going to be an HO is always null hypothesis. You're going to use mu. And what's the claim? So that number there is always the claim. Okay, this number here is always the claim. So one last time, the manager of the project claims that the mean age is 30. Right, so there's your claim. That's it. It's either going to be 30 or it ain't going to be 30. If it's 30, well, you're testing for it to be 30. And if it falls outside a certain region, it isn't 30. That's as simple as it. That's as simple as it is. So step 1, define the hypothesis. Right, now, number 2, this is the important point. With a t-test class, you can't go straight to a z table. You are going to use a t-table. Why are you using a t-table? Because your population is less than 40, or your sample is less than 40. If your sample is less than 40, you use a t-test. There's 2 areas in this calculation. You've got to get the sigma level, or the area of the level of significance, and you need degrees of freedom. Okay, those are the only 2 things you need, and they're very simple if you know what you're looking for. So let me go back to the question. Test the claim at the 5% level of significance. 5%. Right, that's your sigma level here. There, sigma, 0.05. And your degrees of freedom is the sample size minus 1. Sample size minus 1 to give you 9. It's going to be a 2-tailed test. So what are you going to be doing? Because it's a 2-tailed test class, the last thing that I need you to remember is that instead, you're not looking at one side of the tail or the other. You're looking at both sides of the tail. So if you can visualize this in your mind, you're looking at an overall confidence level of 5%. Because you're looking on both sides of the curve, you're going to be looking at 2.5% and 2.5%. So in this situation, what I'm saying to you now, rule of thumb, you take your significance level and you divide it by 2. So you get 0.025. Okay, when you're dealing with a t-test and it's a 2-tailed test, which it should be, you are going to take your significance level and divide it by 2. Now you've got that. Now what are you going to do? You're going to go to your t-table, and some of you may have it in front of you or not, or do it with revision, and you're going to go and find 9 on the extreme left-hand side, and you're going to run your eye along until you get to 0.025, and there's your acceptance regions. Minus and plus 2.262. All right, that's it. That's step 2. So again, let me summarize it for you. If the sample size is less than 40, you're using a t-test. In order to use a t-test for a 2-tailed test, you look at your sigma level divided by 2. Your degrees of freedom are n minus 1, and n is the sample size. That's step 2. Step 3 now is just calculate your test stat. Your test stat class is the one that I have given you here, okay, which is exactly the same as the sampling distribution process. So now you slot your numbers in there. Your X is, remember, this is the claim. There's the claim. That's the claim, and this is what you found. So mu is the claim. This is what you found. Okay, the claim was 30, and they found 27. The sample standard deviation was 20. Size of the population 10. Square root, you get 0.47 minus 0.47. Because this number, okay, falls between minus 2.262 and plus 2.262 class, you are going to conclude that the claim is probably true. If this number here, that number in step 3, falls outside this range, then you reject the null and accept the alternative. The closer this number is to 0, the closer, class, you are actually to the claim anyway. So look at the number here and say, does it slot? Hang on a sec. Oh, here we go. Sorry, right. No, one wonderful question. Here we go. I'm here. Yeah. Here we go. Does it help? Standard deviation of the sample is 20 in the question. Okay, there's your 20. Hopefully that helps you. Okay. So there's your 20. Good question, actually. Someone's still awake out there, so well done. Okay, so that's where your 20 comes from. It's the standard deviation. It's your sample standard deviation. All right. Yes, they will always give you the standard deviation. All right. Sorry about this. I haven't been looking at my chats as well. So there we go. All right. Okay, class. Lekker. Great. I'm afraid I can't. I would love to spend much more time on it, but I think you've got the basics. Now, if this wasn't a question with a number in it, class, if this was a question with a percent, you're going to use the proportion calculation. And here, please remember this. The proportion calculation, class, is always going to have a Z table. Always. The only time you use a T table is when, let me just go back again, this is so important, is if you have got a number and the sample size is less than 40. That's your T test. If your sample size is greater than 40, a Z test. If you're using a proportion and a percent, it's going to be a Z test. The only time you use a T test is, and generally, this is the one they give you, okay, along with this one here, okay. All right, so no, you need to remember them, please. Please remember them. Define the hypothesis, determine the region of acceptance, calculate sample test stat, and then go and do a conclusion. Please, class, remember it. Okay, great. Right, final bit. Okay, I'm pretty sure you're tired. But it's important now you make this decision. I'm pretty sure you've all been through it with your lecturers, so I'm not here. With grouped and ungrouped, my suggestion is perhaps more the ungrouped than the grouped root approach. And with probability, perhaps more the probability trees and frequency tables. With this, class, I can't say to you. They equally. It's a process in hypothesis testing or calculation in chi-test. Okay. Now, a chi-test, class, there's two types of questions. You'll get both. All right. So this one, a so-called type 1 question, is a testing for a relationship. So in other words, before we get into it, they can ask you, hey, there's male and female, and there's these magazines, 3 of them. And they took out a survey, and they want to know if there is a relationship between male and female and people who read the magazines. That's a relationship type question. Or has a pattern changed? In other words, 23 years ago, this is what happened. Now, is it changed? Or not even 3 years ago, this is what they expect, and has the pattern changed from the data you've got? So you're going to get both of them, okay, for a chi-test. You are going to get both of them. Like, for instance, with the stats, you're probably going to get a t-test, and you're probably going to get a proportion. Here, you're going to get both of them. All right, okay. And remember, you can't choose. If you go this question 9 route, you've got to do both of them. Okay, so, sorry, let's go back again. Now I've given you again, and please, class, I know you can get hold of this on YouTube, but feel free, take this photo now, because this will help you in your decision-making process again. All right, so you're going to start up the top here. Is it a type 1 or a type 2 question? They're both going to be chi-tests. Now, and they both got the same formula. So do you see that the process is a lot easier here? Okay, but there's a little couple of other bits and pieces that you've got to remember about. Okay, If it's a type 1 question, you're looking for association, and I'll show you the kind of question. You're going to have a big kind of a table to deal with. If it's a type 2 question, they'll just give you one stream of data, one kind of block of data. All right, we'll look at both. Okay, number 1 type question. First of all, the chi-square stat, that's what it's called, is now this is the stat you're going to use in step 3 rather than the Z or the T calculations that you did in question 8. So this is the one you're going to be using. Okay, and this is the one where the calculations creep in quite a lot rather than in the previous type of question 8. All right, so class, here we go. Let's have a look what they can ask you. They're going to give you a box like this, a table, sorry, generally male and female, and it could be soaps, it could be fragrances, it could be whatever. And they're all going to add up, and you're going to get whatever the number is. You want to determine whether there's a relationship. As soon as they use the word relationship, class, you must know it's a type 1 question. All right. And a type 1 question is then perform an appropriate level, test at 5% level, if there's a relationship between gender and preferred brand of cell phone. So you are asked to perform this test. All right. It becomes a chi test. Class, you can't use T's or Z's here. It's a chi test. You'll see that the tables they give you, that'll be your third table they give you in your exam paper, which has a funny looking kind of curve at the top. It's not a standard normal curve. And there's a reason for that. Okay, so the first one is it association or is it pattern? When they say relationship, you're going this route. Okay, this level down. If it's an if it's a change of pattern, it's this one down. Right, let's move on. Okay, again, step 1, 2, 3, and 4. So drill it into you. Step 1, define your null and alternative. Step 2, your regions of acceptance. Step 3, it's exactly the same principle. Step 3, do the calc. Step 4, have a conclusion. Okay, now the process is the same. The steps are the same. When I say the process, it's different calculations now. So the first thing you must say, if it's a relationship type, this does never change. Okay. Your null is going to be there's no relationship, your alternative that there is. Okay, so it's either that they are totally random or they are not independent and there is an association. Okay, so that's what you're going to be testing for. So that's it. And class, as I've told my own students as well, hey, put this down. Because your lecturer is going to give you marks for it. Step 1, even if you get completely blown out of the water everywhere else, put this down in step 1, and you're going to get probably 2 or 3 marks for it. So, don't throw marks away. Step 2, now we are going to slow down a bit because you determine the region of acceptance. Now, we are going to be doing a different set of calculations now. I'm sure your lecturers have done it, but I just need you to understand. First of all, you need the level of confidence, and in the question it was 5% or 0.05. Then you need to calculate your degrees of freedom. This is for step 2. You're finding it. Now, class, please, before we even start, on the previous question 8s, hypothesis tests, they were two-tailed tests, okay? So you were testing on both sides of the mean. In these type of questions, your chi-square test is only an upper tail test. So you're only going to be looking at one side of the curve. Okay, so make that again. This is important for you to remember. You're not going to be dividing any. So basically the bottom line is you're not dividing anything by 2 here, not like you did in the t-test. Okay, so we've got a significance level, and it is 0.05. And your degrees of freedom are going to be R-1, C-1. Okay, they are not going to give you that, class. You've got to remember it, please. So all your degree of freedom calculations from question 8, which is N-1, to question 9, which in this situation is R-1, C-1. R stands for row, C stands for columns. Rows excluding total, columns excluding total. R, how many rows excluding total? 1, 2. So that's 2. How many columns excluding total? And of course the gender is 1, 2, 3 of your active data. So it's 3. 2 minus 1, R-1, C-1. So it's 2 minus 1 is 1, 3 minus 1 is 2, gives you a number of degree of freedom of 2. get a significance level of 0.05 class, go to your chi-test table now. Your chi-test table, look for degrees of freedom of 2, look along the top at 0.05 and you'll find 5.991. This becomes your acceptance region, okay? And it's the one boundary value that demarcates what you are going to, your acceptance from your rejection, okay? Your acceptance from your rejection. Not like your question 8s, where you had 2 of them and the number had to fall between the 2. This is either one side or the other side. That's step 2. Okay, step 3 is you are going to use this calculation. Your FO is observed, your FE is expected. Your FO is what they give you, your FE is what you calculate. Let me say that again slowly. Your FO is what they give you, your FE is what you calculate. So let's start. Right, so this is your FO. They gave you this data in the question I've just shown you. That's the question, that's the data they've given you. Class, just bear with me while I quickly go back here. There, you kind of need to transpose this data. So where it says Apple, Nokia, and Huawei, you're going to have that at the top, and you're going to have female first and then male. So 20, 35, 43. Remember 25, 35, 43, 20, 35, 43. You've transposed the data down, transposed the male data down. Right. What are you going to do now? Now you're going to find your expected value. Here's your expected value. This is a calculation you need to now be able to do. Okay, so what is this 32.83? Now what we need to do is go back to our table. Now you see what I mean about a chi-test. A chi-test class has a lot more calculations. How do we get to 67 and 98 divided by 200? So now let's think what we're looking for. Apple and female. Apple and female. So let's go back to our table here. Apple and female. All right, so we got to find a mirror. That's frequent. That's your FO. We now an FE. So we need a number down here which mirrors to that, or not mirrors to it, but links to it. So what do we do, class? We take the total of female multiplied by the total of Apple, okay, and divide by the full cohort. Total of female, 67. Total of Apple divided by 200 gives you 32.83. There we go. Let's go down to male. Male and Nokia. So let's go back again. We need male and Nokia. There's male. So it's 102. And the total of Nokia is 66. So we take 102 multiplied by 66 divided by 200, which is going to give you male and Nokia. 33.6. And you do that for each one. So you take the total of female multiplied by the total of Apple, divide by 200. Total of female multiplied by total of Nokia. Total of female multiplied total of Huawei, divide by 2, all of those, and you get these numbers. Do it if you are going to go this route, class. Get this. You've got to be able to get this pretty sorted. Once you've got this column sorted out, okay, then it's simply a question of putting it into the formula. So FO, okay, class, so get this number here. I'm just going to go straight here because what we're doing here is this is an interim spot. So we've taken FO 20 minus 32.83, squared it. Okay, why do we square things in stats mostly? To get rid of the minuses. Okay, and then divided by your FE. So 20 minus 32.83, square that number, divide by 32.83 gives you 5.014. Similarly, moving down, doing all of that, and then summing. Because what you're doing is you're just following this formula. That's all you're doing. And then you sum it. So that's step 3. Now, step 4, as with any hypothesis test, this number now needs to be compared to your acceptance region. In this situation, if it's greater than your acceptance region, you are going to reject the null. If it's less than your acceptance region, you are going to accept the null. So remind ourselves what our acceptance region is. It is 5.991. So we are going to accept the null if your chi-square test stat is less than 5.991, and you're going to not rejected. So what do we have here? 16.438. Is that larger or smaller than 5.991? Well, simply it's a lot larger. So you're going to reject the null because it's larger than that number, because 16 is larger than number, and you're going to by rejecting the null, you're going to conclude that there is potentially a relationship between teenagers and cell phone preferences. Okay, so class, I want you to think about this now, all of you. Question 8s are a bit more process, but less calculation. Question 9s, and I'm going to do a final one with you. Question 9s are more calculation and less process. I mean, look at this. That's the same. It's the same except for the degrees of freedom calc, which is fine. You just either say to yourself, are you looking for a relationship or are you looking for a change of pattern? Okay. With a relationship type question, you're going to have a big block of data like I've just shown you. So you immediately identify it's that. Now, the problem is, though, is the calculations are not hard by any stretch, but you need to get that column sorted out. And by getting that column sorted out, you've got to take the total of each of the female Apple, female Nokia, male Apple, male Nokia, etc., and divide it by the cohort to get those numbers. Then you've got to do the calcs to get to there. If you're prepared to do that and you're happy and you feel comfortable with it, then this is actually a nice one to do. But if you don't feel happy with the way to do this, or you're a bit iffy, then do a question 8 rather, class, because there's a lot more you can kind of get marks for if you don't make a mistake. All right. And then pattern change is your final one. Now, here, students, they're going to give you one blocky. Okay, not like the previous one. So even if you get completely confused, your question 2 will be this one, and your question 1 will probably be the actually, I don't know. I can't say that for certain. The association is going to be a big block of data with gender and three things, and association will be probably one block of data. All right. Okay, and generally it's going to be something along the lines of the thing I'm showing you at the moment. So a financial manager of a store has found that previous experience, so that becomes your expected. 50% of clients pay by credit card, 30 on account, and remainder by cash. He wants to know if there's been a change in the pattern. So the previous versus what you've seen. Okay, previous versus what you now are sampling and finding. So this here, what they're showing you is what they have. You know, they've just sampled it. This is experience. This is what they've got. Now, is there a statistical change on a level of confidence between what they've now got and what they've had? Okay. By all means, it says 5 minutes and left. That's fine. What I can do. Okay, here's the deal, class. Put your email address, or if there's a class rep there, please put your email addresses in there, and then I can send it to you. I mean, you can get it from YouTube when it's loaded, but hey, if you want it as well, I'm more than happy to give it to you. So after this session, if you just put your email addresses in, however, and I'll send it to you, and then perhaps you can send it out to other people. Okay, and your mates and whatever, then it'll help out. All right, so there we go. All right, so exam type question 2. The last one we're going to be looking at is going to be identify. So this is not one of these big blocks. Okay, all right. I think there's a Dr. David de Villiers there. What I will do, okay, fine, not a problem. Ms. Jambela, I'll send it to you. And if what I was going to ask, I don't know how many students are from how many different campuses, but as soon as you get it, I'll send it to you. You just send it out to all your mates as well. It'll help them. Okay, great. Guys, put it down, and I will send out one large email with it if you want them. If not, you'll see it on YouTube anyway. Okay, Leka, so we've got a change of pattern, and we're going to be looking at, so we're going to follow this one down. And again, you can see the formula are all different. I mean, not all different, apologies, all the same. We are just going to be doing a different calculation. All right. Okay, so again, step 1, 2, 3, and 4. And we're going to say to ourselves, payment method has not changed or it has changed. Remember, with association, there is no association. There is an association. With patterns of change, the payment pattern has not changed or it has. Step 1, just put them down. Class, if you've got a question, so question 9, A and B, even if, and I don't like saying this, but heck, even if you get this far, put down your step 1s and you're going to get marks for it. Okay. And that applies to question 8 as well. So build your marks. Apologies. Step 2, determining the region of acceptance. Unlike your previous question, unlike your association, your degrees of freedom are now different. Instead of R minus 1, C minus 1, you got K minus M minus 1. All I'm going to say to you at this stage, I'm sure your lecturers have dealt with it. M is always going to be 0. Just remember, M is 0. You don't need to worry why at this stage. Just remember M is 0 because it's a user-defined category, and K is the number of things you're looking at. So this is the number, this is K. So K is the credit card, account, and cash. 1, 2, 3, excluding the total. There's your 3 there. Minus M is always 0. Minus 1 gives you 2. Again, then go back to your chi test. Degrees of freedom are 2. And you've got a 1% significance, so 0.01. Go to your chi table, look for 2, look for 0.01, and you get to 9.210. That becomes your region of acceptance. Okay. Therefore, again, exactly the same as in the previous question. If the number from step 3 is lower than this number, you accept the null. If the number from step 3 is larger than that number, you reject the null. So let's have a look and see. Right, students. So let's have a look. There's the data. There's the number. What are we going to do? So this, by the way, is a lot quicker, hey? Much, much quicker than the previous one, because now this is the numbers they've given us. Okay, the card, this is what you observed. That's the number they gave you, 600, 250, 150. There's what they expect it to be, which is 500, 300, 200. Okay, and now, hey, you didn't have to go and calculate an FE for each one like you did in the previous one. Those are going to be given to you, basically, in the question. And then you put those through, and then you just redo the calc again using that calculation to be able to get to your final number here, which is you add it all up, okay? And you get 40.83. And you can see substantially 40.83 is bigger than the 9.991. So you're going to reject the null and accept the alternative. Okay, class. What I do suggest is also, I'm sure your lecturers have done it anyway, is just to have a look at some old papers as well. Also go through them and see, particularly the ones you feel. So again, before I finish, because I don't want to spend too much more of your time, you've been here for a good 2 hours as it is that with section A, you have 3 compulsories. So that's non-negotiable. Go through your linear regression, go through your index numbers. I promise I'll send these slides to you as soon as I finish this. I'll send it to all of you. And then, so section A, you can't duck out. Section B, my suggestion is look at ungrouped. Section C, my suggestion is the probability tree or your frequency contingency tables with those, additions and conditionals. And so that would be, and question 4, it's a toss-up between a hypothesis test, which is more process than calc, or a chi test, which is more calc than process. But if you get these slides, which I'm going to send out to all of you now who've asked, go through them, and you've got yourself a week left. So you should be all right. Okay. Okay, class. I think this thing has decided to throw me out. Please have a great one, and I'm sure you'll do very, very well in your stats exam. Try and if you have any issues, I'm going to put my email address on anyway. I know you guys have your own lecturers, but if you need anything else, I'm going to go to chat now. I can see all your guys. all of them there. So that's great. I'm going to put my own email address down if you need any help or you didn't get something. And so I'm going to do it now. And then I'm going to say good luck. And let's see, I think it says that. I never remember these things. Okay. stbrown@varsity-college.co.za. That's my email address. If there's any issues at all, speak to your lecturers, but come to me as well, particularly if it's something I've raised. And yeah, I can only wish you good luck. Take care, guys. Thanks for being there. And once I send you these slides, I'm asking you, please send it to your mates, send it to your colleagues, and it'll all help. Anyway, take care, have a great one, and good luck. Ciao, ciao. Cheers, guys.